1.
Hello, welcome back. Hello, Jarno.
Good afternoon. So I was here yesterday, so I guess I don't need to do much of an introduction. I just go into Jupyter notebooks. And also you were in the morning.
Yeah, yes.
If someone is just joining us now, hello, and let's get started. So what
Jupyter notebooks.
Are we talking about?
Hi, we're talking about Jupyter notebooks and, well, talk a bit about various things. So motivations for using Jupyter notebooks. Then we will discuss how to launch a notebook. We will look at the interface, some of the shortcuts, how to basically make your life easier, at least when working with notebooks. And we'll have a look at a first show here. A first computational notebook, so an example of it. Then we will have a break. And then after that, Jarno will tell us about how to do version control with notebooks, which is an important thing, I would say. So it actually matches the content of the previous week, at least. And then talking about how to share notebooks, right?
So this is also, the sharing notebooks is also a response to one of the questions that came up yesterday. What do you do when all of your code is in a notebook and it's not actually runnable as a program in that way?
Yeah. Well, let's see. I think, yeah. So writing code in proper code, like in text files or in notebooks, well, I mean, it's a thing that we're going to discuss now, I would say. So what are the motivations for using Jupyter notebooks? And notebooks in general, there's not just Jupyter, but there's many other kinds. I think the Jupyter was one of the first widely used implementation of this paradigm called like literate programming, where you mix code with text, with explanations in prose, let's say. And but not only. Okay, so in the case of Jupyter notebooks, I think they are used nowadays for like data sciencey workflows, I would say, and where you need to you have some code that produces some pictures, some plots. So you want to show the plots. You want to show the code that has produced the plots for context. You want also to add some context that you can write. Maybe show some equations and so on. So in a sense, you are documenting your code in yet another way compared to what we saw this morning, right? Yeah, so it's like instead of writing just code, you write a lot of documentation with the code, right?
So I mean, so Jupyter is also, notebooks in general, is also a great way of documenting a library. So you can have your documentation written as notebooks, and then you have like examples of calls to your program that produce some result that then the user can just go and modify and see what happens.
Yeah. And I think that, as we mentioned, you can have Jupyter notebooks in your documentation, your web documentation, and those notebooks are runnable, so you can even validate them. So you can have so it's a way you can basically write a tutorial, make sure with Jupyter, make sure that it runs as it should, and yeah, so that's a way you can have actually automated tested documentation. So stay tuned for automated testing for tomorrow. But yeah, so that's why I actually like Jupyter notebooks. That's what the promise that they have. Yeah, but in general, I think the important, more general, I think more general use of that is when you have like a computational narrative that you want to show. So yeah, you do some data analysis, let's say, and you want to show the results with the code and so on. And yeah, it's great for that, especially if you need to communicate with other people that may not exactly know the code or maybe not even know how to code, but at least they can see the plot and yeah, and get insight with from that. Yeah. So there are some. Yeah, please.
Yeah. So the two things below, I guess, are actually pretty much examples of something that's very useful, where you can essentially reproduce or recreate your paper with a notebook and include the code to produce the plots and all of that. So I can tell the whole story, but doing the math as you go.
Yeah.
Which is
to connect ourselves with
nice.
the topics of yesterday, so like reproducible science. Yeah, that's a quite a boost to that, I would say. Yep. So yeah, so for example, here we have some examples of some notebooks that you can load in Binder. Binder is a platform that allows you to run some notebooks on the web without actually having to install anything on your site. So we will see this later. So Jarno will show us how to use Binder. And yeah, so I will not go into the details here, but here, yeah, to whet your appetite, let's say we have some different example of the of Jupyter notebooks coming from different domains, different scientific domains. Yeah, one about gravitational wave discovery, Nobel Prize, and other things. So something related to humanities, I would say. Yes. So there are some use cases that work really well for us for Jupyter notebooks, for example. Yeah. So we have a really a linear workflow. Okay. With where you need to read data, to filter it, then do some statistic and plot. Okay. And then you want to experiment with new ideas, testing new libraries and maybe databases or whatever. And they're also interactive, so that's one of the great reasons to use it. There are also alternatives, typically with the high-level languages, where you can just turn on like the Python interpreter and see something. But actually, with Jupyter, it's nicer because you can plot in the notebook, so it's a bit easier and more user-friendly environment to actually do interactive work in. Yeah, and you can share explain code to colleagues. For teaching, I've used Jupyter notebooks a lot. Yeah, and keeping track of interactive sessions like a DigitalLab notebook. And yeah, so also, yeah, when you publish articles, you can actually supplement some information for that to those. But there are also some pitfalls, right? So these are very nice use cases, but there are some issues there. So for example, if you don't have a very very simple flow of code, so if it's not linear, then it can be difficult. If you have a large code base, you may actually use Jupyter notebooks as like at the top of this code base, right? So you could you may have some functions that are written in some files and in some proper source files, and then you can import those, like use those in the notebook. But you cannot write your whole code base in Jupyter, I would say. I mean, you can try, but it's very difficult and clunky, and
yeah,
I would not do that.
People often go a bit too far with how much they include in a notebook. But yeah, when you start including functions, for example, then it's probably already a good idea to start moving those functions into a separate file.
Yeah.
Anything that the viewer doesn't need to see probably should not be in the notebook, is basically what I would, like my recommendation, but just personally, basically.
Yeah. I think that one should safeguard himself from it. themselves from doing this by making, okay, you're going to use notebooks, good, but consider whenever you start a notebook also to have basically a background infrastructure where you have some a properly set up project for your own language.
Yeah. I mean, then again, of course, one thing that notebooks are really good for is kind of fiddling around with stuff, trying different things, and then you might in fact have some cells that you don't run and some cells that you run in a random order to get things to work and so on. So like all of these pitfalls happen for a reason, and sometimes there's a good reason for it. So it's just that when you publish it or when it gets big, when you start sharing it with someone else, it is a good idea to clean it up and make it more presentable.
Yeah, definitely. But yeah, the cool thing is that they lend themselves for rapid prototyping, and yeah, so that's actually quite good. So I would say let's go to the next episode in the lesson. I hope we have made the case for Jupyter notebooks, and so we can show how to use them. Let's say a bit. So it's a bit of the basics, but just to make everybody on on the same page. I will now switch switch my share to the terminal, okay, for a moment, okay, and yeah. So here I have a terminal, and here, what should I do here? So I will create a directory called JupyterLab demo, lab demo. Yeah, create that, and then what should I do next? Cd JupyterLab demo. Demo, and then I will use my the conda environment that we discussed about in the previous episodes to start it. So I first of all activate conda, the right environment, and activate code. That's how I call that, and then I should be able just to invoke Jupyter Lab. Okay. Yep, and yeah, and now JupyterLab should be after this huge blob of text.
It will open it in the browser window if it finds a browser.
Yeah.
Or you can also like it tells you that how to open it in a browser if it doesn't pop up immediately, but it's a little bit hidden in all of that text that you just saw. So it's the part that says starts with HTTP and has this token equals something.
I can copy. Yeah, I could copy that, and yeah. But fortunately, in my case, there's no need for that, and I have this beautiful interface that shows me some different things. So let me just copy the notes to know somewhere. Okay, JupyterLab. So how actually does it work? So you have seen that in my terminal, I have actually started JupyterLab, the server of JupyterLab. Okay, there's a web server attached to it. Okay, and yeah, let's show here. I think it's clear from the notes. So this is the program I have started in my terminal. Then in the browser, I'm able to talk to this, to interact with the server, and of course there's a user here. And then the notebook server is able to interact with the file, the notebook file, also with the file system, with everything which is in the folder where you started the JupyterLab server. And in addition to that, the notebook server itself will talk to a kernel. The kernel is not your operating system kernel, but it's like the thing that actually runs the code that was written in the notebook.
Yeah. So the kernel is actually running code. It's interpreting the code. So in Jupyter, like the name actually comes from Julia, Python, and R. So there's like default kernels for Julia, Python, and R, and there's different kernels. Well, yeah, there's kernels for those three languages, but also other languages. So you could have multiple kernels open at the same time, but I guess we'll just have one for Python.
Yeah. So for example, in my case, I have a Python 3 kernel, but since I'm a bit weird, I have also a kernel for Bash, right? Principle, I could do this. I'm not going to use this.
I'm
But yeah,
suddenly
so
wondering
here,
if I do
if you
have
have
one as well, but I guess not. Yeah, so well, you have two different kernels then.
yeah. And there's
Okay.
also for C++, for example, if some of you is interested in having C++ developed in a notebook, then you can also use C++ there.
Why not?
Yeah. So other things we can let's have a look at the interface. So it's better to do this here because it's a bit there's more stuff here that I can show. So here there's ways to actually create a new. You have a file browser. You have a way to create new files. Then here on the, so if you want, you can actually collapse this navigation bar on the left. Then here on the right, you have the notebook, and you can see that the notebook has different things. So you can have like two kinds of cells. So the content of a notebook is organized in cells. You have markdown cells, which are your prose, your content, your comments that contain also formulas, for example. Then you have cells, code cells. Here, for example, you have a code cell, and then you have also input, the output, right? So
I wonder if you're
you have,
pointing at something with the mouse, and maybe we don't, or I don't see your mouse.
oh, okay. Yes, unfortunately, not my mouse is not visible.
It's interesting.
Okay,
Well,
so
but there is so the gray, light gray areas are code, and the white areas with text are markdown cells, and I guess we can show how that works.
yeah. So wait a moment. Can I get back to that? Okay, good. Yeah, so we'll show that. There will be plenty of time to show this, and yeah. So the can show here two kinds of cells. So there are markdown cells, and yeah, you have all the features of markdown there. So you can create headings, you can create links, you can have bold, italics, strike through, also code which is inline. Can you see this? So you can, if you need to type code, but
yeah.
in a not in its own cell, but in the, you can do that. You can have lists with bullet points, or yeah, or numbered lists, equations, and so on. So these are all the things we discussed previously. We showed previously in when you use Markdown, and then you have code cells. Yeah, so yeah, code cells. And yeah, and you create these two kind of things. Code cells have also outputs, and it goes on like that. Yeah, so so the interface has the JupyterLab interface has a little some shortcuts, something we'll discuss now about this. So
Yeah,
let's
those are the kinds of things that it's better to check when you have used it for a moment. But I don't wait too long though. So okay, so what should we do next? Should we
I think we
start
should open
this demonstration, the first computational notebook?
Yes. So here in the notes you have a discussion on what are the shortcuts. But yeah, so I'll start a first computational notebook, and I think I can get rid of this so that everything fits. But yeah, if you want to back your navigation, you just click on.
Yeah, so that's a file view. So it shows the folder that you started Jupyter in, and well, I mean, it is very similar to a lot of other file system process. But yeah, so one thing is you created a new notebook, and the name is Untitled.
Yes.
By default. So it's usually a good idea to change that.
Yes. So how do I name that? Let's see if there's an an idea on in the notes. Let's say my first notebook, or like, how could I do that? Let's call it. Well, we want to call. So the example here wants to calculate pi using Monte Carlo method. So what would be a good name? Like, wait, have to.
So the
pi Monte Carlo.
Yeah, that's fine.
Good. And now I can close this. So we have space. Okay. So what do I do? First of all, I want to add a. So I change the. I want to a markdown cell here. So I will press M so that actually the kind of the cell turns to markdown. So I can type a header.
So if you don't remember the shortcut, there's also this. There's multiple layers of user interface, but just outside the notebook there is a menu bar that has this save icon and then a few other icons, and it includes this text markdown. So it's currently markdown because it's showing that the current cell is markdown, and you can change it to code or raw. Raw is just text, so it's pure text. It will not get changed when you run it.
Yes. Okay. So Monte Carlo method. Yeah. And now I want to create a new cell. So I usually press Shift Enter. Okay.
So should I maybe? I mean, I can draw here.
Can you?
Okay. Or not?
No. Wait.
Can you see? Let's go back to the preview.
No, I think you can't. You cannot really draw.
No, I cannot draw there.
It's alt black.
Yes. We have some weird issues with the screen share.
Yeah, it's always weird sometimes.
So do we try? Maybe I'll click this again. No, it sometimes comes back.
Let's see.
Do I start sharing? Do we try resharing? Maybe it's 25 past already. I suggest that I start. Okay, well, it's back.
Okay.
No, it's gone again.
It's back. Okay.
I suggest that I start sharing.
I'll stop sharing then.
Yeah, not quite yet, I guess. Oh, no, I'm sharing something.
Yep. Okay, so I'll stop my share then.
And now the Zoom thing is in the way. Okay, sorry about this, but stuff happens. So is that okay? So I have activated the CodeRefinery environment, and I'm going to run JupyterLab. There we are. So it started in the browser window.
Here it is.
Now let's pretend that I don't have this file already here. I'm going to create a new file here. Okay. Why do I have an untitled folder here? Let's delete that one. Okay. So, and I'll call this pi.ipynp. Okay. And we had already the markdown cell. So I'll just very quickly write some title there. This, I made a mistake now because I was going too quickly. Right? So this is now a code cell, and it's actually it's a comment because it starts with a hash. But I want this to be a markdown cell, so I will go here and change it into markdown, and then press play to run it. Okay. And the other option to run it is to press Control and Enter. Or at least that's one other option. There's other shortcuts as well. Okay, so that inserted a cell below it. Shift Enter doesn't enter. And Control Enter maybe creates a cell. Okay, Shift Enter creates a cell below it. Okay, so what do we do then? So, and I'm guessing we do want to actually make some calculations. Well, first, we have a list of relevant formulas for this calculation so that people can follow along what we're doing. I wonder if I should just hope. You can
so
reopen the cell by double clicking.
Yeah. You can show some formulas there which can be useful. Yeah. And also to show.
I'll just copy paste so that I don't spend too much time writing it out. But it's Markdown, which you have already used in the notes and in the documentation session. Okay, so here we are.
Beautifully rendered.
We also have an image visualizing the content. So this is kind of fun. You can include an image either from the file system. So I'm going to go create another Markdown cell. But here we're actually including it from GitHub. You can navigate to the file in GitHub and get the raw, open the raw image, and then get the link to get something like this. Okay, so that's fun. But let's get to coding. So first we need to import some things. And I keep pressing Shift-Enter to get a new line, but that doesn't work. I just keep creating new cells. I need to get used to this again. So import random. We're going to need random for random numbers. Just enter, not Shift-Enter. Okay. And for plotting, we're going to need matplotlib.
iplot, actually, from matplotlib.
We probably shouldn't spend too much time on the code itself. It's, I mean, the basic idea, yes, but like the code is in Python, and like the language shouldn't be necessary. It shouldn't be necessary to understand the language or use Python specifically. There's plenty of other options out there.
The idea is that you compute pi, because pi is going to be close to pi divided by 4 is going to be the probability that a dart thrown in a square is also in the circle.
In the circle, yeah.
Or similar or equivalent.
That multiplied by some number, I think.
Yeah.
So we were calculating the area of the circle by randomly picking numbers and deciding if they are inside the circle or not.
Yeah.
So first, let's pick a number of throws.
It says num points equal 1000.
Points. Okay, and run that. And then we can write a function that throws the darts, which means picks two random numbers, an x coordinate and a y coordinate. Okay, so throw darts. Actually, the function throws a dart, right? Again, I press Shift-Enter instead of, okay. So let's initialize, well, actually, yeah, we throw darts because we're not doing a function, we're doing a for loop at this point.
Yeah.
I was reading incorrectly. So here we go. So we make a list of points and we'll count how many times it hits inside the circle. So at the start, this is 0. Yeah. Then we will do a for loop and we don't really care about the index, but we want do it number of points times. So this is a for loop. If you know a different language, don't worry about the syntax. It is a bit weird, Python. Okay, but we'll get an x coordinate and a y coordinate from random. So that means if there is a random contains a function called random, we will be calling it twice. Yeah. Okay, to get two random numbers. And then
we need to check if they are inside.
Yeah. So how do you check if it's inside a circle?
The Pythagoras theorem. So
we'll do x squared plus y squared and the size of the circle is 1. So we're picking from between 0 and 1. So the square is from 0 to 1. I'm checking quickly if people can actually see me. And so the square is between 0 and 1, and so the radius of the circle is also 1. And 1 squared is 1, so we don't even have to square it. Okay, so if it is inside the circle, then we say hits, add 1 to hits. And in any case, we actually want to keep track of the points. So we'll append the XY coordinate. And
but we also,
we'll want to mark whether it hit or not. So we could say true or false here, but actually just for the plot, we want the points inside to be red and the points outside to be blue. So I'll go a bit fast here and like immediately mark it as red. Because we've already stored the number of hits here. Okay, and then if it didn't hit, we'll want to still add the point, but we will make it blue.
Yeah. I think you need another bracket there.
Yes, I do.
Yeah, because you're appending a tuple to the points.
Specialty of Python. Yeah, it's a tuple. Yeah. Okay. So we have already run that. Now, if I want to check what happened, I could just say hits. So hits, there were 765 hits. I could say points, and that would be a long list. Okay. So
wow.
Yeah, so it's nice. You can just check what the variables contain. It's like this is why it's useful for rapid development, right? But let's actually make it more of a narrative. So let's see what the result looks like. So we'll make a plot. So we'll take the X and Y coordinates and colors and extract that from this. So this is, again, don't mind the syntax. It's weird. Let's say what it's actually doing. So extract the coordinates and colors.
In this case, you're getting a single list for all the X, the X's, another list for all the Y's, and then a list for the colors.
Yeah, exactly. Okay, and then we define the figure dimension. So define what the figure looks like. And this is for subplots. This is just how matplotlib works. So again, I just skim past it. What is important here is that you can do this plotting thing inside JupyterLab or inside Jupyter, and it will work. 0 is not a good size. I want to maybe go with 6, I think. Okay.
Inches and
yeah, 6 inches. I don't know why we use inches here, just standard. Okay.
Yeah.
I mean, in general, in plotting, why do people use inches? But that's just the standard. So we plot the results. We did get this x variable here.
That's axis
the
representing.
Axis, not an axe like for chopping, but axis. We'll make a scatter plot with the x coordinates and the y coordinates listed, and then C for colors. So we need to set C equals colors here. Okay. And this should now, instead of this long list, produce a plot. Let's see if it's presenting. Okay, there's an error. That's
a little, yeah. So there's you called fix. So if you go a line above,
there's a fix. Okay, so it's not a fix, it's a figure. Yeah. Okay. All right. So here we have a plot. So we have some points outside and some points inside the circle. Okay. Now that's not the actual result, though. This is like this shows the method we used, but the actual result is the value of pi. So that's if you look at the equation here, it's the number of hits divided by the area, which in this case, the area of the square is actually 2 times r squared. So it's 4. And that's not, is that correct? Well, I mean, the area of this square is 1. So I guess this S actually means the area of this square. And the C is the number of the fraction of the hits.
Yeah, I think this applies for the quadrant or for the full.
Yeah.
Yeah.
Okay. So. Well, I mean, we'll do it correctly here. Anyway, I'm not sure if I'm reading that correctly. So the number of hits divided by the number of points is the fraction of hits. And then the pi actually is just 4 times the fraction, which I guess is what was written down there.
Yep.
So I'm just somehow confused. Fractions does not exist because I added an extra s there. Okay.
You see here how errors happen, right? So with how errors are displayed in Jupyter.
Yeah, that's maybe I should do that again just for a moment. Yeah. So I mean, the colors make it actually easier to figure out what's going on, but it's on line 2 of the previous of cell 13, input cell 13, which is this one. This is an output cell, or this is actually an error. This is an output, this image here. And well, there's also markdown cells, which I think also count as input. Okay, well, let's get rid of the error. So 3.06, I mean, that it's 3, it's close enough. We can get some more points if we want to and run again. So one thing I do want to show, because it was something at least I use very often. If you're making a narrative from top to bottom, you probably want to run the cell from top to bottom. So here's restart the kernel and run all cells. This is also useful to do before publishing. It just makes sure that if you run everything in the original or in the written down order, then it should work. Okay, so it is running all of the cells. Now this is so many points. The image is just an image of a circle at this point, and we have slightly a slightly better estimate of pi here. Okay.
Yeah, but so important here that if you change one parameter, you need to, I mean, you need to run all the cells again. I mean, to be safe. You can be clever, try to be clever, and rerun only the ones that are. But yeah.
So what I could do is change his here, run here, and then just try to go to this one. But now I get a completely incorrect result.
Yeah,
because
that's funny.
I didn't change the stuff in the middle. I just changed this variable. This didn't run and this didn't run.
Wow.
So if I run that one, now I think I will get the correct result, but the image is not quite correct. So at this point, I'm confused. I'm going to rerun everything. It's often better to rerun everything often than it is to like try to figure things out.
Yeah.
Yeah. Okay. That's the example. Anything else we want to bring up here?
Check if there are any questions in the notes, but it doesn't seem so. Yeah, but yeah, I think one comment in the notes is about Marimo notebooks. And yeah, so there's a number of other like Jupyter alternatives that, for example, Marimo, I think it's for Python, but also Pluto for Julia instead. And these are kind of notebooks that compared to Jupyter, they have something more. So they are reactive. So if you change, for example, in those notebooks, if you change one cell, if you change like num points, then all the other cells that depend on that would actually run. And this is, I think, it can be useful. Of course, if you have cells that take very long to run, you may be careful about doing that. But still, like it's like a little improvement over Jupyter from the point of view of reactivity. From other things, I think there's a lot of tooling around Jupyter notebooks that we are going to briefly skim over, and which is, which unfortunately doesn't apply to other kinds of notebooks. So yeah, but that's why I think we teach Jupyter notebooks. I don't know. Should we have a break now?
Yeah. So I mean, R has its own sort of infrastructure, and R Markdown has most of the features. So you can do things like, well, I mean, it has most of the same features that we haven't actually talked about yet. And Pluto is also kind of designed to work well with version control and stuff like that. But Jupyter still has the most mature environment because it is the oldest of these examples.
Yeah, there are validation tools. There's a lot of stuff there, which is cool. Yeah. So anyway, shall we have a break now?
Let's take a break now.
Not? Okay.
So we'll do 10 minutes until 13:52.
Yeah, we'll write that in the notes.
Are you writing it down?
Someone is doing it.
Someone is doing it. Okay, good.
The invisible hand.
Thanks. Doing. Okay, so see you at 53 past or 7:02. Right. Bye.
Bye.
Okay. Hello. Welcome back. I hope you had a good break and took some time to walk around. So next we'll go into how you share notebooks, how you include them in your software, and like just have other people use them as well. And that starts with version control. So the notebooks themselves, especially, maybe I'll just show the notebook again. So this one includes an image. So it can be, it's not actually text content, and Git is designed for text. So if you use it with just the default stuff, it can get a bit weird. But I mean, it's not that bad. It does work. So there's a few different ways of making it look better. So there's the nbdime extension for Jupyter and JupyterLab, which is very useful. It allows you to more directly compare and merge notebooks. So it is aware of the cell structure here, and it can tell you what has actually changed in the cells in the notebook, and doesn't point out every change in outputs necessarily, and so on. So that's useful.
Also
there's
for
also
images.
Other option. Sorry.
So also for images, if you have plots, then they're saved in like a blob of text base64 in the notebook file, and yeah, with nbdime you can actually have a nicer.
Yeah. So we have we will show that in a moment. Well, maybe it's better to just list the options from here. And so I mean, there is also this JupyterLab-git and JupyterLab GitHub extensions, which are useful depending on what you use. Here we'll show nbdime and also show some things on GitHub. So yeah, so the first thing, I guess, we'll just show what happens when things go wrong. So here's an image. I can actually open this pull request or a comparison between two different versions of a code in GitHub. Let's see what it looks like. Well, it doesn't even want to show it to me. It's a large diff. So we've changed some things in the notebook, and then there's this huge blob of text, which is actually the image. And the image is a bit different. In some part of the image somewhere is a bit different. It's very hard to see what's going on. There's also this text output cell here that's slightly changed. So there is an option in GitHub that you can enable. It's been a, what do they actually call them? Feature preview. I think it's been a feature preview for several years now. But you go to the feature preview from preferences section and enable rich Jupyter Notebook diffs. Okay. And then if you reload the page, it should look very different. Let's see if it works. Okay, so this line in the cell has changed, this line has changed, and this image has changed. So that is a lot better. And well, this output has changed here. You can also go back to the original source code, which is, for this part it works, but for the image it's not very useful. Okay. So maybe I will close this one. Okay. And there is a similar, well, there is an interface for Git in JupyterLab itself, and that is this nbdime extension. It's already installed in the CodeRefinery environment, but if you're creating a new Python environment that includes Jupyter, then, or well, any other environment that includes Jupyter, you'll have to include it for it to work. Okay. So we already, I think, kind of showed the actual text that the notebook contains, but maybe we should do that again. So here's the file browser view, and I think I should be able to open it from here. Yeah, open. So this is actually a JSON file, which is a text file that contains these cells. This is even a bit too stylized, maybe to maybe I can open it with the text editor. So this is the actual text content of this file that we just wrote here. So it is text, and it is something that you can handle with Git. But well, here's the image again. Yeah. And all of these outputs get changed every time you run the cell. So I mean, there's just a nicer way of doing it. It's not that bad to start with. The image part is pretty bad, but so here's the nbdime extension. This is the button that gets added when you install nbdime. And there you can, first of all, I need to initialize a repository here because I haven't done that yet. I don't have a Git repository, so I will initialize a Git repository in this. And now I have some untracked files, which is, I don't actually know what these checkpoint files are. I assume it's because I have JupyterLab open. But this is the actual file, py.ipynb. And this is the example I downloaded previously because I wasn't planning to actually demonstrate this part. So
now you stage the
yeah, so
file.
I staged the py.ipynb by clicking the plus button. So
and what happens if you change that file py.yn? So if you change that, because now it's staged, right? So if you change that, you should see
so I was planning to make a change. So now it shows up in changed. I can view the div. Maybe I should hide this view here. So it's mostly the same. It should show me the. So this is the line that I changed. What is going on? Maybe I need to. Maybe it's showing me the diff to the commit. That would be a bit annoying. Diff this file.
Have you changed the file? Have you saved it?
I changed this and saved it.
Okay.
So now it's back to the original, and now it's showing some changes.
Okay. I guess you need to save it, right? Because then if you don't save it,
if you don't save it, then it's Git doesn't see it at all. But yeah, I mean, this is, I think we found a bit of an issue with nbdime. I've never actually tried to do that. So if I just stage the file and commit first, and then try the diff, maybe that will work. Let's see. Okay, so I'll just call this an initial
commit as
commit. Traditional commit message.
Yeah.
And then what should we change? Let's change this color from red to orange. Okay, now you already see that there's some change, and we can go see a diff. Maybe it will work this time. Okay, so now
Okay.
a bit more space for it, so we see that the line has changed. But actually, I have only changed this line. I haven't changed the actual color. So let's go and
You need to rerun
So
the
now
whole
we
thing.
change the image as well. And we can now again go here and see what the difference is. Okay. Did I save it? No, I did not. Let's go and save it. Clicking here. Okay. And okay. So it didn't show any new differences, but now that I click this button again, now it shows some differences. So I had to close it and reopen. And now it's showing a difference in this image and in the outputs. Let's remove that there. So the outputs have changed because I reran the code, and it's random, so it's going to be different every time. Okay, so now, yeah, we can kind of nicely see the difference here. I haven't enabled this in the command line, so if you are using Git in the command line, I will need to activate, activate the CodeRefinery repository. I should have thought about this before I started. Okay, can't activate CodeRefinery. All right, here we are. And now if I do git diff here, it's going to show me that the JSON file. So this it's relatively structured, relatively nice to read. I don't really care about the execution counts for the cells or this, whatever this is. I do care about the image being different, but this is not what I want to see. So you can also go to, well, I mean, go to the notes and copy paste this, or get it in some different way. So it's you change the git config and include nbdime in there. Okay, that looked weird. I was moving to a different window to get the terminal window back, and that looked a little bit weird on the screen share. Okay, so now I can do git diff again, and let's see what it looks like. Is it different? It is a bit different. So now it's not really showing me the image, it's showing me that it's different, which is better, right? That's like how much can you do in a terminal? But it is definitely better this way.
Yeah.
Okay.
Much less useless information in the diff, I would say.
Yeah. Okay, so but we should really move on actually. I will comment this. Okay, orange, change to orange. Oh, I will need to first stage this one and commit. Okay, so let's move to sharing notebooks now. So we talked about version control. And again, there's different ways of sharing a notebook. So there's some free, some commercial alternatives where you can, let me back up a second. So the big thing here is if you share something online just as a web page that people can see, they will not be able to run the code. But there's plenty of ways to do that. So you can take this notebook and turn it into essentially a text that includes this, or a website that includes the text, and then includes also these code blocks and images. And that's really nice. That's really good for generating documentation, for example. But you won't be able to run the code from inside that website. And then there's plenty of options for creating a runnable shared document in some way. And that does mean that you need a server that actually runs the code. So we'll show you how Binder works as a demonstration. It's a really nice way of doing it. and that allows people to actually run the code. But there's other options, and this NB viewer is renderer, NB Sphinx. They allow you to turn the notebook into a website. So not run the code, but otherwise great. So one option, save and export as HTML, LaTeX, Markdown, all kinds of options. And then there's these platforms that allow you to actually run it on the cloud. And well, and there's Binder. Okay, so first let's. Sorry. Okay, yes, I was confused for a moment. This is the next part. So let's go into the Binder section. But to do that, we'll need to get the notebook actually online. So now it is only here, only locally on my laptop. So I think we'll actually need to create a new GitHub repository. That is actually the first step in the exercise, right? So that's good. So here's a nice link, github.com/new, and that will create a new repository. I didn't want to actually close the website. Okay, yeah. All right, so we will not use a template. What should we call it? CR demo PyCalc. PyCalc is written correctly. Okay, so this is it's not actually short and memorable in any way, but it is very descriptive of what this is and something I will delete after sometime after this this course. So I'm going to make it public so that everybody can access it. And importantly, I'm not going to generate a README file. No, I am going to generate a README file. And then I'm going to, I guess, clone and add the notebook. Okay, let's see where this goes. So I will add a README file. It is nice, a nice thing to do. It's just that I already have a GitHub repository. No, I already have a Git repository, so it's I'm not going to use the same one, I suppose. Okay, so let's do that. Why not? Let's also add a license since we're at it. Make it MIT, for example. We talked about licenses yesterday. It's good to have a license early, right? Okay, and you can make it more restrictive later if you want to. Here we are. So we have a license and a README file. The README file is pretty much empty. Okay, so
now you need to add your code somehow, right?
Yeah, so now I'm going to actually just add the notebook and not push from the repository. And I guess that the reason for that is that in the first demonstration, we did not make it a Git repository, but I did actually make it a Git repository already. So, well, anyway, let's go with the exercise as it's described. So I will go from here, upload files. And I guess choose files then is good. Where is it? This is dots. Okay, I'm going to have to move my windows a little bit just to see. No. Source, CodeRefinery, Jupyter. Here we go. Okay. There's py.ipynb. Okay. And then now I need to give a commit message. So add the notebook. Okay. Commit directly to the main branch. Yes. Okay. Now there is another thing that I will need to do before
the requirements.
Yeah. So in order for so we're going to run this on Binder, but in order for it to know or to be able to run it, it needs to know what other Python packages I need. So I'm going to add another file. I'm going to call it requirements.txt. And do we have a list of this? If this is so, if we switch to the R
matplotlib 3.4.1.
Yeah, what I was going for is So if you use Python, it will recognize it from this requirements.txt file. If you want R, you will need to add a runtime.txt, and it will recognize that you are using R if you have this file. You can even have both at the same time. So what I'm going to do is add a requirements.txt and add matplotlib. And I'm going to use a specific version just because it is the version that I know it works with. And
it's good for reproducibility.
Yeah. So in a moment, you will see that Binder actually creates a container to run this code in. So this will work pretty well. Okay, create requirements.txt actually is very descriptive here. It's pretty much, I mean, I could say describe dependencies or something, but this is good. Okay. Now the next thing we want to do is go to mybinder.org, and it opens this website. And actually, I'm going to switch over back to the repository and just copy the name of the repository. So that's my GitHub username, and then the repository's specific name. And that goes here. Now the name of the notebook is pi.ipynb. Okay, I'll just put that there. Pi with i.ipynb. Okay, so IPython notebook, and from the main branch. So this is a file that it opens to the user by default, but you can leave it empty and then it will just open a file browser instead. Okay, so this actually constructs a web address you need to go to launch the website. So we could click launch here, but actually let's add a batch to the README file. So we'll have a markdown file, and it has this address to this Binder logo, and then the address that opens the Binder as a link. So let's just copy that. This button is about copying, and change the README file. Okay, so this will add a image that allows people to quickly recognize that there's a Binder, that this repository works with Binder and that you can open it. So let's save that file. I should do it with the mouse. So commit changes, add Binder button to README. Okay. And let's again commit directly to the main branch. And there we are. So actually, let's go back to the main page of the repository. So now we can actually launch the Binder page from here. So I will go and close this one and hope that this works. Okay. It takes a while to build a new container, right? It's actually waiting is done. So we already have a virtual machine that we are running stuff on, but we are now waiting for the container to finish building so that we can actually run JupyterLab inside that container. Okay. What else should we go through while we wait? So I've did all of these instructions, I think. Yeah, so people can now go and look at my work in the cloud. If this finishes correctly, if it doesn't, then we'll fix it. Yeah, well, let's go on while it's doing its thing. So yeah, you can go even better, of course, get a DOI and launch a full version of your software. Should we, how much time do we have and how much stuff do we have to go? So, we have plenty of time, I think. So this exercise is about sharing, doing it yourself, which you can definitely do after this session. And this is about playing around with this inequality repository, which we talked about in the first section. If I was this fast, then what did I skip over? And so yeah, if anything is unclear, please ask questions. And if you want to do this yourself, you can follow the steps, try to do the same steps that I did, and feel free to ask questions then later. I mean, yeah, a good amount of the time usually in this exercise is waiting for Binder, so we can have a chat about other stuff as we wait.
I have actually a remark. So regarding tooling for Jupyter, so there's one Python program called nbdime, which can be used to validate your Jupyter notebook. So if you have a Jupyter notebook and you want to make sure that you have run all the cells, and you want to test it, for example, test if the output is the same in different environments, or even after you have changed some underlying code that sits somewhere else, you can use this tool nbdime and get just an idea whether or not anything has changed. And of course, in this particular case with the calculation of pi, it would always give you an error because it's random.
Yeah, if you are comparing the value of pi to the correct value of pi, then it will not be very
or
close.
If you are comparing two random values of pi, you may have a problem.
Yeah.
So here, possibly for reproducibility, you would have to set the seed of the random number generator.
Oh, right. Okay. So if it's it's correct.
But in any case, so comparing two notebooks, maybe so you need to be careful there, because there are some things that perhaps there can be some differences you don't actually care about. Some differences instead are significant and may mean that there's a problem. Some instead not. So yeah, but I think it's a valuable tool. Anyway, finally.
Yeah, that sounds useful. And I mean, tomorrow testing is tomorrow, right? So
but
tomorrow
finally
we'll
loaded.
also talk about how you compare, for example, random values. So that's one of the things, and automated testing in general. So, okay, it's loaded and it shows exactly the same JupyterLab interface, except without the Git interface. And I can run everything in here. I can also change the numbers and run them. So I get a different result. Ooh, that's a problem. Okay, let's finish running. So yeah, with 100 points, you don't get very close. We have a 2 new version of NumPy compared to matplotlib. So matplotlib is trying to use something from NumPy 2. So either I need to set a newer version of NumPy, a newer version of matplotlib or a different version, or I need to use a different version of NumPy. I will not have time to demonstrate that now. I'm almost sure.
Is there a possibility in Binder to set up a container and tell it use this container instead of just saying a requirement file?
Oh, I don't know. I mean, I would assume so, but I don't know. That also sounds like specialized enough that it's, well, we can figure that out later. And if somebody else wants to know, just ask. There's also often, so you can run some terminal commands, bash commands, for example. Okay, so can I do pip install upgrade matplotlib. Oh, right. Okay, there's a space there. There shouldn't be a space. Yeah, so this is one thing you can do in Jupyter. That you can try to get it to work. Then I guess I need to restart the kernel. So is that something I can do from here? Oh, actually, that is this this button, restart the kernel and rerun all cells. So we'll see if the error goes away. This is just trying to fix some small thing. Okay, all right, here we are. Now it runs. So to fix this, I would go to the repository then and tell it to use a newer version of matplotlib. Okay. Next, we have the feedback section again in the notes. Let's see, where do I have the notes open? Here. So let's go there, unless you have more ideas. So
I think time for feedback.
Yeah. So yeah, please fill in any feedback you have and ask if you have any questions. We have a few more minutes in the schedule, but so we can respond to any questions. But otherwise, just have a nice day.
So maybe there are some questions we can go back to and try to go on.
Hello.
Hey.
Hello. So I think the question about Jupyter notebooks and version control, yeah, I think we cover that. I hope that the person who wrote that is satisfied. I think that sometimes if a Jupyter notebook is too long, it doesn't show on GitLab, but you may actually, so it may take time, but if you press on the button show anyway, it should show it. Although it could be that if it contains images and the images are too large and the notebook is displayed as literally, so not as image but as a JSON file, then yeah, you get very large files, and there won't be any interesting information for you to visualize there. And yeah, I think there's a question about reactive notebooks. And so what do people think about reactive notebooks? I think we mentioned this already. The one thing about this about reactive notebooks is that they do not contain the output. So for example, Marimo and also Pluto do not contain the output, and that they are just plain Python files, so they are easier to version control. But on the other hand, yeah, you miss the computational narrative there, so you don't have the outputs. So it's like a very different kind of tool, I would say. What are your opinions on this?
Yeah, I mean, you can, with reactive notebooks, for example, with Pluto, you can still export it as an HTML file, export it as a website, and then it will contain the outputs as well. It essentially is just running the notebook and including the outputs. But the source code for the notebook doesn't contain the outputs. Like in the source code for a Jupyter notebook is, well, it is this JSON file that I showed, and it did contain like the full image as this huge blob of text. So it contains all of the outputs there. So it's a different philosophy.
Yeah, one could take this kind of reactive notebooks and execute them and add add those the content of that to your documentation site or to your GitHub pages. Let's say one could do that to make sure that that content is visible somehow, so that the results are visible. Yeah.
Well, no new questions here. Okay.
There's a question about the connection of Git connection in JupyterLab. Is it whether it's similar to Git in VS Code?
Yeah,
looks like it.
It
right?
looks very similar. We saw a couple of glitches maybe that wouldn't happen in VS Code, but yeah, I mean, the nbdime thing is just meant for working with JupyterLab and Jupyter Notebooks. So the version control system that's included in VS Code, or essentially it is a user interface for Git. It is fully general.
Yeah, I think there's possibly a distinction that, if I remember correctly, the Git extension, the Git source control for VS Code looks at the state of the files you have in your editor, not at the state of the files you have saved on disk. So this is yet another problem. So sometimes that there can be some issues there, because Git in VS Code looks at the code you have in your editor, and it can be different from the one that you have on disk. So if I understand correctly here, nbdime and the extension in JupyterLab looks at the state of the notebook as it is saved on disk. So then there was that problem where we were
Git should always look at what's saved on disk. Okay, I have to try that. At least there's a way of getting VS Code to look only at what's saved on disk. But yeah, it depends on what you're used to. So what is more useful?
Yeah, just saying, this kind of Git extensions, Git integrations, they can get a little weird because of this additional state that they have, the state of the file in the editor, and the state of the file on disk, plus all the other things that Git has. So all the stage version and so on. So it's, it gets messy.
Yeah, I mean, it is already complicated enough with the separate staged, committed, and on disk version. And well, then you do also have the version in that you have currently open if you haven't saved it. So
yeah. There's a comment for the day's lesson that it's missing hands-on activities. And yeah, we know of this problem. So in previous years, we did, like, all the exercises you would see here, we actually did together. But since people have different backgrounds, like, we have mostly them in Python, some in other languages, but it was basically too much. And if we gave enough time for everyone to do the exercises, we'd basically spend all the time on the exercises. So instead, we can look at it like this. So we have the demos, and the exercises are there for you to do later on your own time, if you would like. And maybe someday we can go back to trying the exercises, but with the difficulties of installing stuff and managing everything, it's
I mean, if you do want to try the exercises, we do have the notes as a way of asking questions. So if you have problems when you try them, you can always ask question in the notes. And yeah, you don't exactly have to follow us when we do it. You can just go ahead and start doing them and like turn off the stream, or do it now after the stream.
So I think for the documentation, I see how the bring your own code sessions would actually work, because you have maybe some, but possibly also for Jupyter Notebooks, maybe if you're interested in this, in how to integrate Jupyter Notebooks with your documentation also, the bring your own code sessions may be useful there. So you would apply what you've seen today, but directly to your to what you're working on, instead of some artificial exercises, which still would be nice, but maybe you can make a longer jump and go directly to applying these things to something new. Because it's also nice that people are saying, okay, I will use what I learned today. That's quite, there's quite a number of O's there, which is pleasant, I think.
Yeah. And if you have anyone locally you can talk to, you can basically show them exercises and say, I would like to do this. Can you be my mentor? And they can give you the starting advice, like let you know if it's the right thing to do for your own environment. You do it and you ask them for help. And if you're at any of the organizations where any instructor of this workshop has been, we're around to help you. Unfortunately, we can't help everyone in the world because, well, you know, we're a few people and this is an open course. But yeah, I guess you know how that works. Let's see. And tomorrow, yes, if you can scroll up a little bit, there's some news for tomorrow there. Yeah. So tomorrow we have 2 lessons. One is testing, which is a very practical thing. So it would have some really nice exercises if we were giving you time to do them. But we sort of combine the version control, the GitHub, and many other things, and show you how you can use GitHub to test your code on every push you do, and integrate that with pull requests and so on. So it's really cool. It's a quite good thing to do. And I think that if you're just following along, you can still get a lot of it, even without the exercises. That's easy to do later. And then after that is modular code development. And this used to be a sort of discussion thing. Now you get to see 2 instructors come together and they will start with a basic idea, make a code in a Jupyter notebook, and slowly make it more and more modular. Add functions, split it to files, and eventually end up with a program that can be run from a command line. And there's a lot of general discussion here, so to say. Like, it's really, how would you say it? It is, if you ask me, it really puts everything together and shows a realistic process from chaotic initial scientific scripts to something that's reusable. Yeah. Okay. Any other news for tomorrow? Or should we get going?
Yeah. Looking forward to tomorrow, actually. We've been in the background.
Yeah, okay, great. So see you all later then. Please keep filling out the feedback and all.
Thanks.
So
all right.
see you later. Bye.
See you in JupyterLab.
Bye-bye.